Sergio here, and welcome back to Physics Made Easy. Now what I'm going to show you today is how to solve this sort of problem here. And the only reason I'm showing it is because I personally had a bunch of trouble with this problem before I finally figured it out. Now, the premise here is you're on a train that's traveling at 3 meters per second along a level straight track. Very near and parallel to the track is a wall that slopes upwards at a 12-degree angle with a horizontal. So that's what this area here is showing. As you face the window, right, this is what I didn't figure out at first. This is the window in the diagram here. So the height is 0.87 meters, and the width, that's a crooked line, oh well, is 1.9 meters. As you face the window in your compartment, the train is moving to the left, as the drawing indicates with this red arrow here. And the top edge of the wall first appears at window corner A, and eventually disappears at window corner B. How much time passes between the appearance and disappearance of the upper edge of the wall? Now, to basically explain what's going on is there's a slant in the ceiling, as the problem states. So the top of the tunnel, or the side of the tunnel, is moving up like this. And you and your train are just traveling along this flat line. So you're seeing the part where the wall touches the ceiling go upwards in your window here. And I know, that's the most beautiful train ever. Choo-choo. Anyways, the way we solve this is actually fairly simple trigonometry. So first, we have our triangle here. And so I'm going to start writing that off to the side. We have our triangle. That's terribly ugly, but oh well. What we know is that this angle is 12 degrees, because the problem told us that the slope is 12 degrees. But now the question is, what's all the other parts of the triangle? And so what we're trying to solve here is that from the first instant that we see it in this bottom left corner A, we're trying to solve how long it takes, if we're traveling at 3 meters per second, so that it disappears in this top right corner, corner B. So a way for us to solve that is just to calculate the distance between this initial B and this final B. Or it also works with A, but I'm just going to be using B. Is that this initial B, that's when the ceiling is first seen, and at this last B is when the ceiling is last seen. So basically, we're trying to solve for this distance between the two B's here. And so what we can do is first we can start off with this triangle, which again is a little crooked, I know, sorry. And so we have our height here, because we said earlier that it's 0.87 meters. And what we're trying to solve now is this long side. So for the long edge, what we can do is, if you remember SOHCAHTOA, T equals O over A. So our tangent equals the opposite over the adjacent. And so if we grab our calculator, the tangent of 12 degrees is, and I'm actually going to be typing this out here in real time, so the tangent of 12 degrees, which you should just be saving in your calculator anyways, but I'm just going to be rounding for sakes of showing this here, it's going to be about 0.213. And so 0.87 over A equals 0.213, because 0.87 is our opposite over here. And so In order to solve this, we get 0.87 over 0.213 equals A. So I type that in the calculator, and I'm going to be using second answer. I'm not actually going to be typing that out. We find that A equals about 4.09. Again, there are more decimal places that you should keep on your calculator, but for now, we're just going to keep doing it this way so that I don't, lose all the space on my screen. And so what we finally solved here is this distance between the far right edge to the far left edge of the two windows. So if I draw this out again, and here's A, here's B, here's A, here's B, what we solved is this gap between this bottom right corner and A. And remember how we explained before that we need to solve the distance between the two B's? Well, that's actually really easy at this point because they gave us that the window is 1.9 meters wide. So our 4.09 meters, all I have to do to find that distance between the 2 points of B is 4.09. And again, that's a rounded answer, or it's 4.093, plus 1.9, which in this case is going to give us 5.993 meters. But again, there's extra decimals. But that doesn't tell us how many seconds it's going to take. But from here, it's fairly easy because we're traveling at 3 meters per second. So, if we're traveling at 3 meters per second, 5.993 meters divided by 1, or multiplied by 1 second over 3 meters is going to give us an answer of about 1.997 seconds. That's supposed to be a 7 down there. So, 1.997 seconds is our answer. And just to let you guys know, there's already a little check mark there because I solved this problem first to make sure I knew what I was doing before I made this video demonstrating how to do it. And so I hope you guys found this episode helpful, and if you have any other questions, feel free to leave a comment. If you liked the video and the video helped you, please leave a like. If there's anything I can improve on, again, let me know in the comment section. And if you really like the help I'm giving you guys, feel free to subscribe. But until next time, have a great day, week, however long it takes. See you guys next time. Bye.